So for 8.2, we're going to discuss a few more things about a binomial distribution. First of all, you need to know what a PDF is. And a PDF stands for Probability Distribution Function. And it assigns a value to each value of x. And more importantly, on a calculator, PDF applies to just one value of x. Sometimes you can remember PDF as point. So let's go on. And also, just so you know, in class we're going to talk about how to use the TI-84 to do a lot of these calculations. We're going to do some by hand right now. CDF, Cumulative Distribution Function. And we're going to calculate probabilities from 0 to x for the number of successes in n trials. Remember, binomial is always about counting the number of successes. And this is a p less than or equal to. So CDF is a less than or equal to. Let's go on. Here's a binomial coefficient. We need to know this because it's convenient for one, and for another thing, it appears in the AP test a lot. And the example here is, how many ways can we choose 4 books in a collection of 6? So just, if we're going to use this formula, or any formula, we first need to make our shopping list. So we have n and k. K is the number of successes, which is 4. And n is my sample size. So in this we would have 6 factorial over 4 factorial, 6 minus 4 factorial. That gives me 6 factorial over 4 factorial, 2 factorial. 6 factorial can be written as 6 times 5 times 4 factorial over 4 factorial. And then 2 factorial is really just 2. So the factorials will cancel out. The 2 will go into the 6. And we're left with 15. I highly recommend you write down this formula. It may come in handy sometime. And here's an example. And I'll pause the video, and you can rewatch this if you want, how to use a binomial coefficient. But this is a number of ways we can arrange k successes among n observations. So binomial probability, we take that binomial distribution. It's p to the k, so in other words, a probability of success to the k, q to the n, which is our total number, times k minus 1. And this is a reminder that q is 1 minus p. So I do have an example problem here, and I will set it up for you. So again, whenever we are dealing with any type of formula, we are going to make our shopping list. Here we need n, k, p's, and q's, because those are the variables that are over here. N is our sample size, and our sample size is 5. K is success, and here success is defined as a defective tire, so that's 3. The probability of success, which is 0.2, and the probability of not success, which is 0.8. So to set this up, we would have 5 factorial, 3 factorial, and then 5 minus 3, which is 2. We have p, which in this case is 0.2, to the 3, 0.8, and then n is 5, k is 3. So 5 minus 3 is 2. So that's 5 times 4 times 3 factorial over 2 and 3 factorial. These will cancel out. This will cancel out. So we have 10 times 0.2 to the 3. Oops. Let me fix that right quick here for you. Point 2 to the 3, 0.8 to the 2. And if we do some mathy stuff on this, we would get 0.008, 0.64, and then a 10. And I don't know that I can do all that in my head, but I can use my calculator here real quickly, and we can multiply these three values together, and that should give me the probability that exactly 3 of 5 tires are in fact defective. So we have to ask ourselves, what type of problem is this? Is this a PDF problem or a CDF? And I'll tell you, this is a PDF problem. The reason why it's a PDF is because it's a single point. We're not saying what's the probability of 5 or fewer. We're saying what's the probability of exactly 5. So just so you know, when I multiplied this all together, I got 0.0512. Okay, and that's it for video 2.